This is the piece of stock that we're going to use to make the fixture for our swivel plate to bolt up to. This measures almost 7.5 on the OD. I'm not sure what this is. This might be a piece of ductile, but I really don't know until we start making some chips. And we'll machine a boss on there, drill and tap it for a stud, use a flange nut to pull this up. And on this inside right here, measures 7 inches. So once we face that off there, you'll have a nice face right on this outside area here for it to pull up to. Now it won't be contacting here. I really wanted something bigger so that it would pull up on both surfaces, but I didn't have any other stock. This was the best piece that I had on hand. So we'll chuck this up and get this machined into our fixture. We've got our jaw set right here to accept our piece of stock. Just push it against the face, and we're going to let that square that up. We'll face this side off. Put a button tip on the end of the indicator. That'll work good on this kind of stuff here. That's within a few thou being in the center. That's going to be just fine. Just double check all the jaws, make sure they're all equally tight. We'll let it run right where it's at there. I'm not sure what grade that is, but it's definitely not ductile iron. I think it's a tool steel. I think that's a material that we have had in this shop for a very long time. I'm thinking back to my late teenage, early 20 years when we had some parts that we had to make. I remember we made some parts about that size and then sent them out to have heat treated, and then we had to have somebody grind them. So this may be some kind of tool steel. Chips are sort of a purplish color as they come off, but that's something I've had in my drop pile for years and years, so we're just going to use it. I made a reference point there that's a little bit bigger than our finished OD of our register. So just a witness mark that I can bring my tool up, set at 0, and then we'll be able to face that into that diameter there. Pretty simple. All right, let's try facing this off. I'm not sure what to expect on the tool life here or what the feeds to speed should be, so I'm just going to wing it to start with. I'm going to speed it up a little bit. All right, there's my 0. I swapped out inserts. That first one that we started with there burned the tip up. I've been using these Walter inserts here. So what we started with was this is the grade, the WPP20G. It's a medium rated insert right there for medium machining. I've got this one installed right here, and this one is the WPP30G, made for roughing. So we increased the feed to 15 thou per revolution. And you know, we're still taking, I don't know if I told you, I'm taking 62 thousandths a pass, so 1/16 each pass there. It could probably handle more than that, but we're just going with that. And hopefully, we'll see if this other insert will last a little bit longer. And I'm probably not running the correct surface speeds on this either, because whatever this is, some kind of tool steel is definitely tough. This is going to be our last facing pass right here. So what I wanted to point out was how noisy the headstock is using this gear. We're in 238. We have not proven out every one of these gears in this headstock here. So we're still learning about the machine. It's working fine, it's just real noisy. So I'm wondering if some of those gears in there might have some damage to some of the gear teeth. Maybe it's missing some gear teeth, I don't know. We'll get into it one of these days and find out. Just get that turned to our 1 3/8 diameter now. just get this guy chamfered and we can move on to our tapped hole. Let's give it a test fit. There it is. Looks good. All right, drill and tap it for our stud, and then we'll have a washer and a flange nut to hold it up on there. And that'll provide a good fixture to face the back side of that off. That's a technique that I've used many times to drive a tap in a part like that. Just take it nice and slow, and you can feel it with your hands, the pressure as it approaches the bottom of that hole. Whenever it feels like it's starting to get tight, it happens pretty quick. You just let go. You got a 3/4 inch hold down stud. It screws all the way in there just like that. That's going to work. All right, so it looks like I'm going to end up having to make a bigger washer because this isn't going to go all the way down. Threads don't go past that flat. Yep. I might have a piece of 3/4 inch all thread. That might be what I just got to go look and see. We might just cut us a piece of all thread. Shorten that stud up. All right, we just cut a piece of 3/4 all thread. See if that'll work. Got washer on, and then our flange nuts. There we go. Unfortunately, a socket to fit that nut is still a tool that I do not have in the box, so we're just going to have to come in here with Dad's 18-inch crescent, make this happen. I think that's going to work mighty fine. All right, we get our tool touched off, we'll make a cut. I am running 126 RPM, so it's going to be just below the 580 surface feet per minute for this Walter insert right there. And that's for that full diameter, which is just over 16 inches. There we go. Got a pretty nice contact pattern there too. Let's see. 1, 2, seeing what it's hitting. So it's hitting 3 out of the 4. Not bad. Use our mag back indicator here. Let's take a 25 thousandths cut. I'm gonna go ahead and kick the feed up while we're at it. I'm gonna go to a 15 thou feed rate, so it doesn't take all day to get it done. All right, how'd we do? You know, that looks a lot more even than I expected it to be right there. Just a as cast surface. Not bad at all. I think our insert's doing good too. Let's reset and make another cut. So let's take a measurement before we make another pass and see what we need to take off there. So this, according to Jason's print, specs out at 1.7 inches thick. So we can reach these two machined areas right here with our calipers. So it looks like we're measuring about 1.756. So it looks like 56 thousandths to come off that. I'm not going to take that in one cut. Let's just split that in two and just do another 25 thousandths cut. I have noticed out here on these ears, we have just a little bit of chatter, and that's consistent with all of them there. And that's because we have this area that's really unsupported, that's hanging out. So you got a little bit of flexing and vibrating going on whenever that tool hits that. So we still have another cut to make, you know, a little over 25, about 25, 30 thou. So what this is telling me, I'm gonna have to end up taking maybe a couple of very light finishing passes on this to try to minimize the deflection that this thing is pushing away from that tool. We're down to about 15 thou that we need to take off that, and just keep in mind that that thickness on that's not super critical, okay? If you take a little more, take a little less, it's not a big deal. But you might be able to see that. We're still getting a little bit of chatter here on these outside ears until you clear up past the hole there. What we may try for this is get it down to about 5 thou. We still got about 15 to go. So actually we may just try it now. Get a brazed on tool, like a Micro 100 brazed on tool. That has a ground sharp edge on it, and that may help eliminate some of this pushback and chatter that we got on that versus using a carbide insert. So one way that I'm gonna try to fix this so that we can get through our last cut, you know, we want a nice even cut all the way through there, because if this is pushing off, that means it's not gonna be flat all the way across there. You're gonna have a few thousandths deviation in there. I'm gonna go with, I got a couple of my Micro 100 brazed on tools, and I have re-honed these guys. We've got a pretty nice radius honed on that guy. I used my carbide grinder with a diamond wheel, and that's got a really, really sharp cutting edge to it there. I've got another one here. This is one that I had already put a pretty good size radius on in the past, and if you can see that shiny edge there, that's where I hit it with the diamond wheel on the carbide grinder. So it's got a very nice sharp cutting edge to it there with a big fat radius. So the difference between using a tool like this, you have back rake, okay? You have a sharp cutting edge there all the way around the radius where it's making contact with your workpiece. In this case, we're only touching 10, 15 thou, so there's not a lot of contact there. I pulled this insert out just for reference because it's a little bit bigger. You got to kind of look at, it depends on the carbide insert, but most of your general negative rate carbide inserts are just molded. There's not a sharp edge there. If you zoomed in on that really, really close, it would just look round all the way around that edge. So a tool like this actually pushes against the workpiece much more than a sharp cutting tool like this right there. So my hopes is that with the sharp tool, as it's coming in here and cutting, you have less deflection that way of your workpiece, and it's getting underneath that cast iron and shearing it off, versus the carbide that's really trying to shove against it. It's almost like looking at a really, really dull knife and a really sharp knife, or maybe a butter knife versus a chef's knife, something like that. So we'll give it a try and see if this is actually gonna fix it up. So I've got my big Armstrong tool holder here for a 5/8 shank, and we'll stick this guy in there, tighten her up, and we're gonna give this tool a try. See if we can finish it out. All right, we're gonna take a 10 thousandths cut across here and see if it cleans it up. I'm running it a little slower, 106, with hopes that this is gonna be just a finished pass. So it'll take a little while to get across there, and that's one of the downfalls of some of this kind of work here. Let's give it a try. 10 thousandths feed rate, by the way. If it continues to try to ring, then we may have to slow it down again. Sounds like it's wanting to ring. Yeah, I wanted to stop it and see how it's doing. It's doing the same thing. It's trying to ring on us. It seems like it doesn't want to come out of there now. So this is really giving us the fit. We need a much larger fixture plate than what we're running on, so it'll help absorb the vibrations through this area of the cast. I'm gonna let it finish that cut so it's at least even all the way across, and we'll probably try cutting it again a little bit slower. So our tool did a great job there, but our workpiece is not cooperating with us. I'm really surprised that the chatter seemed like it got worse with the sharp tool. So I'm gonna take 1 or 2 more passes across here at a very slow RPM to see if the reduced RPM is gonna help eliminate the chatter. I gotta try to get underneath that. This is one of the problems. Once you get chatter in a part like this, that's doesn't have a lot of support behind it, the cut wants to follow the chatter pattern through there. So it'll take a while. I'm gonna slow it way down and go super slow. I really only have 5,000s to bring it to spec. If it doesn't clean it up in the next 1 or 2 very, very light passes, we may come back and revisit this with maybe either building a large fixture for this to support it, or I may even see about outsourcing it and having it ground on a Blanchard grinder or something like that, just to get it all completely flat and smooth. So here we are on that low RPM. With any luck, we might be able to clean it up. I'm actually running 30 RPM on this, and I went another 2 thou. It'll cut a little heavier on those ears because of the deflection. So far, it's looking better. This is what I hope to be our last pass across there. So the previous cut that you just saw was our first slow RPM pass. And it nearly cleaned up all of the chatter on those ears. There was still a trace amount of chatter left in them. I measured it with the calipers. We were 0.003 over our spec. So we went ahead and backed up, and I took 2 more thousandths there on the dial. We slowed it down from 30 to 25 RPM, and it's doing good. I haven't really been hearing that ring. There may still be a little bit of chatter left in there, but I feel good that this is gonna clean up most of it and be relatively flat all the way across there. So I think this is probably gonna be our last pass. This is the kind of stuff that you have to deal with on certain jobs. You know, you get some of these projects in the big lathes, you get these big parts out here, and sometimes high RPMs isn't the answer. You got to slow things down and take your time and let it take its time to do the cutting that it needs to do in order to clear things up. So I'm enjoying running the pacemaker. We're just kind of sitting back right here watching it do its thing. When it finishes this cut, we'll show you what it looks like. I'm happy to say that last pass is the one that mattered. It turned out beautiful. We actually have a really nice surface on here. It's very smooth to the touch, and it looks good. It cleaned up all that chatter. So those slow RPMs and that sharp-edged brazed on tool was the ticket there to try to get it the size. And let me grab my calipers here. I believe we even finished right on size there. I think maybe about 1,000ths or so. 1,000ths or so over. So it looks like with the calipers, 1.701. Finished it right where we wanted it. I'm real happy with that. I was getting a little nervous that I wasn't going to be able to get that chatter out of there just because we have nothing back here to support this outer end, but that worked good. So sometimes the slow RPMs and a sharp edge tool is just a ticket to get a nice finish on a workpiece. So I think this is going to wrap up this video for our swivel plate. We've got both sides of it machined, which is what the goal of this operation was. I do have some more that I would like to do to this. That's not necessary, but because this is my own personal project, I want to kind of go into it a little bit further, kind of make it my own, make it a little more personal. On the other side of the ears here, I think I want to set it up in the mill and just run a face mill up inside here to clean up that surface where the bolt holds it down. I think that would be a nice touch. That's not something that's done for the manufacturing of these vices that you purchase. That operation is not done, but because this is mine, I think I'd like to do that and make it a little bit nicer. Maybe like a 2-inch face mill or something. We'll get in there and cut that. I also wanted to point out the hole diameter there is already oversized for 3/4 inch hardware. So I don't see a need in actually drilling these holes. They should be on center. I'll verify that they're on the proper hole pattern, but you can see that's a 3/4 stud. And this is measuring with calipers around 825 thou. So I don't see the need to open those holes up. We'll probably just leave those as cast and just deburr them good. I still need to go around and deburr that sharp edge on the outside. I'm just going to do that off camera and probably hit it. It doesn't even really need hitting with Scotch-Brite. It's so smooth. That is such a very, very nice surface finish on there. Our brazed on tool did an excellent job of that right there. I wish I could share with you guys all of the jobs I've done through my career of doing things like this, where you run into problems when you're doing these large jobs like this, and you have to be a detective at that point and use your experience and knowledge to try to rectify the situation. We all want to make a face cut across there quickly and get this job done, but because of our fixture being a little smaller than it should be and we don't have the rigidity there, you saw that we run into chatter problems there because this piece is trying to deflect whenever it's hitting that tool. So the really slow RPMs and the sharp edged brazed on tool there did the job. We made 2/2000ths passes across there and it cleaned it up beautifully. And I'm real happy with it. So we still have a lot more for this Hardtail Vise project, a lot of different machining ops. We're going to use several different machines to get this job completed out. We're going to be bringing the shaper in there. I believe I'm going to use the Kearney and Trecker horizontal mill for some of it. I even want to go to our CNC machines and use those for some of this project there as well. So I hope you enjoyed this video. I hope you've been enjoying the project, and I hope that I see you again on the next episode.